When astronomers look up into space, they can tell if stars are in motion. They can tell if planets are moving and whole galaxies are moving. Well, how in the world can they do that? One of the things I think is interesting is our closest neighboring galaxy is known as the Andromeda Galaxy. The Andromeda Galaxy is moving towards the Milky Way. I mean, actually, we're moving towards each other at about 250,000 miles an hour. Now, what that means is every 4 hours of your life, you have moved 1 million miles. And it might seem crazy, but because there are 6 4-hour periods in one day, every day, you and I are moving 6 million miles closer to the Andromeda Galaxy. And I mentioned that because hopefully to help give you a concept of how incredibly vast and big space is, because it doesn't seem like we're moving that fast, but we certainly are. So how do astronomers determine the speeds of things like stars and galaxies? What they use is something called the Doppler effect. Now, you may not know the name, the Doppler effect, but you certainly know what it sounds like. Now, here's the official definition, and yes, you definitely need to know this definition. The Doppler effect is defined as the change in the frequency of a wave due to the relative motion of either the source or the observer. Here's a classic example. You are standing on a street corner and an ambulance or a police car is driving towards you. And as it passes, the frequency or the pitch of the sound changes. Now, I'm about to make funny noises, so here goes. So as the ambulance approaches and passes you, the sound switches from going rum. It is a higher frequency when the sound is approaching you and a lower frequency when it passes you. One more time. Rum. And you are used to this. This is one of the ways that we know if your back is turned and a car passes you on the highway. You know, if you're standing on the street, you can hear that change in pitch or change in frequency. So if you have the source of a wave that is moving away, the sound has a tendency to sound lower. Vroom. It goes to a lower pitch or a lower frequency. Now, because light is also a wave, it also obeys the Doppler effect. If we have a star that happens to be moving away from us, it's going to look redder than normal. Instead of having its light be where we expect maybe lines of a hydrogen atom would be, all of the lines are shifted further into the red. If a source is moving towards us, the sound is going to be higher in pitch. Vroom, towards us is high, and then away, and then color-wise, light is going to be bluer. So you're going to have any sort of star or planet that is moving towards us, the light is going to appear bluer than normal, and a star or planet moving away from us is going to look redder than normal. And this is called the Doppler shift. If you have a emission spectra from some sort of a star, and the star was standing still, it would look like this. If it was moving away from us, it would be shifted towards the red end, and all of the individual lines would be there. They would just be a smidge off, a smidge further towards the red than normal. If that star happened to be moving towards us, the light and the wavelengths of light would be shifted slightly bluer if it happens to be coming towards. Now, this is useful not only for determining if stars or distant galaxies are moving away from us. If we look at an exoplanet, exoplanet are extraterrestrial planets, planets that are way out in space orbiting other stars. We can determine how fast they actually rotate or spin. Well, how in the world can we do that? Because these planets look like tiny little dots around those distant stars. How we scientists do this is if they look at the light from one side of the star and it's shifted towards the blue end of the spectrum, we know that end of the star is moving towards us. If we look at light from the other half of the star or planet, it's actually shifted towards the red end of the spectrum. It is rotating away from us. And we can determine by the shift, we can determine which direction it's actually rotating, and we can determine the speed of rotation. The Doppler effect pops up lots of times in astronomy. This is just our first introduction of it, and we will have more later. So I'm going to ask you to watch a little video on this, and that will end this section. See you. Bye.